Following a dramatic episode, the most successful probe in history has returned. Data from all 4 instruments is now being returned by Voyager 1, and the mission is still ongoing. Voyager 1 has now penetrated deep into interstellar space and is providing us with unprecedented impressions from there, but what had actually happened? Why did the probe send garbage data for almost half a year, and what stroke of genius was used to repair? Voyager 1 was considered lost the location. Of the probe was still reasonably clear, but the data had been unusable since the fall of 2023. The NASA Control Center in Pasadena only received cryptic messages consisting of ones and zeros that made no sense for months the team fought to save. The probe then came to the sad day when NASA announced that the Voyager 1 mission was probably over for good. What a joy it was when the return of the probe was announced just a few weeks later. Voyager 1 is back after drama in the fall of 2023. Voyager 1 began sending incomprehensible data to Earth communication, which had worked almost smoothly since the mission was launched in 1977, was suddenly disrupted. Scientists and engineers at NASA were at a loss for months, the gibberish told. NASA engineers that the scientific instruments on board the space probe were still functioning, but the data received could no longer be interpreted. This caused extremely worried the probe, which is more than 20 billion kilometers from Earth, is a vital tool. No probe has ever transmitted data from interstellar space before, so NASA is doing everything it can to get this veteran of space exploration has resumed. Even the most clever technicians and decoding specialists initially failed to decipher the probe's messages in order to make inferences about the error. However, the first breakthrough occurred when a scientist from the Deep Space Network that keeps an eye on the probe's communications was able to read the message for the first time. Although it was good to know that Voyager 1 was permanently transmitting a full imprint of its memory and regulation system, these systems function as the probe's heart and brain, the way it was transmitting data was off-kilter, and further troubleshooting proved challenging. The primary issue was the great distance between Voyager 1 and Earth. Radio signals take almost 22 hours to traverse that distance in a single direction. Therefore, it took over 2 days for any diagnostic procedure to be completed. At first, the engineers concentrated on the flight data subsystem, which is in charge of encapsulating and sending the scientific data. A particular specific chip within this subsystem may not have been operating correctly, according to preliminary examination. In February 2024, NASA's mission manager made a public announcement that the mission was gradually coming to an end. After months of intense testing and attempts to determine the exact cause, engineers at NASA worked tirelessly to develop and test various solutions, but it seemed like all options had been exhausted. The team's morale plummeted, and the prospect of humanity losing contact with its most distant ambassador in space was difficult to bear. Millions of fans of the probe around the world were anxiously awaiting the news. NASA kept scientists and space enthusiasts up to date on all posting attempts to share progress and candidly admit disappointments. Although there was a lot of sorrow, there was still hope since some engineers persisted in trying to revive Voyager, and suggestions for doing so kept coming in from professionals across the nation and the world. NASA made the decision to continue and take an intriguing new approach. The plan was straightforward. The problematic code was moved to a different part of the SDS, but there was a chance that this would result in permanent radio silence. The procedure necessitated exact timing and coordination. Each signal transmitted to Voyager 1 needed to be precisely calibrated to prevent additional harm. April 20th, 2024. Voyager 1 was once again sending comprehensible data to Earth after months of work and countless hours of dedication. Can you imagine the joy and jubilation at NASA when the data made sense again? It got even better when all 4 of the space probe's scientific instruments that are still relevant were fully operational again. Voyager 1's voyage was once again thrust into the realm of pure space legends by this triumph. After the issues of 2021 and 2022, The scientists and engineers worldwide celebrated the successful repair of communication with Voyager 1, which was not only a technical but also an emotional triumph. This was the second successful repair on a probe that is more than 20 billion kilometers away and has been traveling through space for more than 45 years. The story of Voyager 1 will continue, and who knows what secrets it holds. After the successful resumption of the mission in April 2024, Voyager 1 is once again at the forefront of interstellar research. The space probe has already provided historical data on the outer planets and the border regions of our solar system, and it is now penetrating ever deeper into the infinite expanse of interstellar space and exploring unknown regions. However, the incredible continuation of Voyager 1's mission is still in store for us. The probe could continue to send us data for another 10 years or so. The batteries will most likely eventually fail in the mid-30s. In order to better understand the structure and composition of space beyond the heliosphere, where our Sun envelops itself and its planets in a protective bubble of particles and magnetic fields, scientists are looking to measure particles from interstellar space and conduct research on cosmic radiation and magnetic fields. Beyond this bubble, a completely different kind of space begins. Since Voyager 1 is the first probe to examine this region, plasma waves are especially intriguing because they should provide information about the density and movement of the interstellar medium, which will help us better understand the entire universe. Since this medium comprises the biggest portion of the galaxy outside of our Milky Way, the knowledge gained will be extremely significant for astrophysics. Starts with the even larger intergalactic space. We have no idea what is actually happening there. What we have learned so far has been based on guesses, computations, and assumptions. Some of these assumptions have been validated by science, while others have proven to be utterly false. Voyager 1 proved this once before when it crossed from the heliosphere into interstellar space. Scientists had imagined the threshold to be quite different and interstellar space also surprised them with a higher particle density than expected and indefinable plasma flows. Who knows? Voyager 1 may even find evidence of previously unknown objects or even exotic forms of matter. Such discoveries could have a revolutionary impact on our understanding of the cosmos. One particularly exciting possibility is, of course, the discovery of traces of extraterrestrial technology or signals. What is certain is that Voyager will continue to fly for hundreds of thousands or millions of years after the end of radio contact. In the event that the probe encounters other intelligent civilizations, at some point it and its twin probe, Voyager 2, have golden records on board with a greeting from humanity. When and whether these messages will end up in the hands of other life forms is truly written in the stars. It will take Voyager 1 a whole 40,000 years to approach the nearest star on its route. B445, the Voyager 1 Hall of Fame. When the Voyager mission was launched, many of you were probably not even born, but generations of scientists worked with the amazing discoveries of Voyager 1 and 2. In honor of this remarkable mission, let's take another look at its greatest accomplishments. Can you imagine how long the data and accomplishments of the Voyager mission have been with us humans? In 1977, after making multiple maneuvers and traversing the AST belt, the Voyager 1 probe arrived to the gas giant Jupiter in 1979, after launching from the Cape Canaveral spaceport in Florida. After examining Jupiter's upper layers and taking close-up photos of the planet's marbled surface and great red spot, Voyager 1 made a stop at Saturn. Voyager 1 started its journey to the solar system's edge after the flyby showed the intricate structure of Saturn's rings and Titan's atmosphere, while Voyager 2 explored the outer planets Uranus and Neptune following its first mission to Jupiter and Saturn. From a distance of 6 billion kilometers, one of the most famous pictures in space travel history was captured. The probe traveled through the Kuiper Belt and farther out to the edge of the solar system toward the end of the heliosphere. In 1991, Voyager 1 snapped the Earth as a pale blue dot to say goodbye. After nearly 20 years of silence, NASA turned the equipment back on and Voyager 1 resumed collecting data. The researchers wanted to know what the magic threshold between the sphere of our Sun and interstellar space is like. In 2012, the time had finally arrived, and Voyager reported an incredibly jerky transition that was so abrupt that it was a solid particle that our Sun builds up. We have been getting data from interstellar space for 12 years, and 4 of its plasma wave instruments are still in use. The threshold at the edge of its zone of influence functions as a thick protective skin. The density and temperature of charged particles, which are more uncommon in the interstellar medium than in the solar system, but carry entirely different charges and most likely have different physical characteristics, are measured by Voyager 1. The cosmic ray apparatus finds high-energy cosmic rays to examine their makeup and, more importantly, their peculiar origin. For instance, because rays lie in total darkness, they may reveal details about structures or objects that we haven't been able to observe up to this point. We can also obtain similar information from the magnetometer, which gauges the interstellar magnetic field's strength and direction. Hints. In order to ascertain whether interactions between the solar wind and the interstellar medium can still be detected farther out in space, the probe also uses a particle detector to detect low energy particles. Click subscribe immediately to see the always fascinating new films that will be released.